Good morning. My name is Francesca Bozzoni, and I am a researcher at the European Centre for Training and Research in Earthquake Engineering, the EUCENTRE Foundation, based in Pavia, Italy. Today, I will present the deployment of a multi-sensor system for real-time seismic monitoring of a strategic port located in southern Italy. This is the outline of my presentation today, which includes the definition of the framework and the aim of this presentation, a brief illustration of the main features of the port of Joya Tower, which is our testbed, the deployment of a multi-sensor monitoring unit within the port area in the framework of a European research project called TURNkey, the development of algorithms at EUCENTRE for implementing an effective earthquake early warning and a rapid response to earthquake system. The presentation will be concluded with a few remarks. Let's start with the framework and the aim of this presentation. The TURNkey project is a European research project funded by the European Commission and starting in 2019, and it will end in 1 year. The main aim of this project is to close the gap between the theoretical system and practical application in the framework of the improvement of the seismic resilience before, during, and after a damaging earthquake. The purpose of the TURNkey project is to set up a platform, which is a multi-sensor-based earthquake information system, which should facilitate the earthquake forecasting, the operational earthquake forecasting, and enable the early warning and the rapid response actions. The TURNkey tools, algorithms, and the platform will be demonstrated in 8 test beds. There are 6 European test beds. They are shown in this map on the right. And there is also the test bed number 7, which is a worldwide test bed, and the test bed number 8, which represents a mobile European test bed for aftershocks. In this presentation, I will focus on the testbed number 5, which is the port of Joya Tower, an important, critical infrastructure located in southern Italy. Let's start with the description of the port of Joya Tower. This seaport plays a strategic role in the maritime transport network of both Italy and Europe. In Italy, it is important because more than 1/3 of national transshipment traffic takes place at the port of Joya Tower. But this port is also a strategic hub for container traffic in Europe because it is located in a very good position in the Mediterranean Sea, which is one of the busiest seas in the world. The port of Joya Tower, as shown in this map, is located in southern part of Italy, in particular within the Calabria region, which is the region in Italy characterized by the highest seismic cancer. The port of Joya Tower, in this framework, plays a key role for civil protection rescue operation by serving as a priority entry point into a territory potentially affected by strong earthquakes. The main infrastructure of the port of Joya Tower is this artificial channel, more than 200 meters wide and about 3 kilometers long. The port includes 8 docks with an extension of more than 5 kilometers. It is important to point out that for container transshipment, more than 3 kilometers are dedicated within the port area. In the framework of the TURNkey project, a multisensor monitoring unit has been deployed within the port area of Joya Tower. This multisensor unit includes 10 low-cost sensors, which has been installed within the port area for seismic ground motion and structural monitoring. This unit includes 6 strong motion seismographs. They are Raspberry Shake, which include both velocity and acceleration sensors. Moreover, 4 low-cost double-frequency GNSS receivers has been deployed within the port. This receiver has been deployed thanks to the support of EUCENTRE, which is a partner of the TURNkey consortium. The location of the sensors are shown in this map, which present the port of Joya Tower. In particular, in these pictures, the multisensor unit are shown. This table presents more details about the main features of this multi-sensor unit. In particular, as you can see, point 1 is referred to the sensor that we deploy to monitor a wharf in the northern part of the port. The same applies for point 2, dedicated to the monitoring of a critical infrastructure within the port. It is a wharf structure in the southern part, point 2. Point 3 is dedicated to the structural health monitoring of a building, of a strategic building within the port area. The point 4 is the local reference for the other sensor located within the port. Tools and algorithms are currently under development at EUCENTRE for processing the streamed data with the final aim of implementing an effective system for earthquake early warning and rapid response to earthquake. Indeed, we are developing algorithms for estimating the ground shaking on the port area, to assess the earthquake-related damage to port facilities. For example, we developed fragility curves for the most important infrastructure components of the port of Joya Tower. And we set up also simulation-based methodology to quantify the induced losses by addressing the multi-component nature of the port system. The port of Joya Tower is a complex system where the single elements are interconnected. And at EUCENTRE, we developed a methodology which is able to address the interdependencies among port elements. To conclude, I would like to say that within the framework of the European Research Project, TURNkey, a multi-sensor system has been deployed within the port area of Joya Tower. Joya Tower is a critical infrastructure in the European framework. The final aim is enabling an effective implementation of an earthquake early warning and rapid response to earthquake system. Tools and algorithms are currently under development at EUCENTRE in order to process the streamed data from this multi-sensor system. I would like to point out that an effort is currently underway to address and possibly reduce the uncertainties associated with the different steps involved in this general approach. Finally, by leveraging on the implemented algorithms and tools, a risk-informed decision support system will be delivered for the port of Joya Tower in order to mitigate the earthquake impacts on this critical infrastructure. I would like to acknowledge the support from the European Commission. Indeed, this research has been carried out within the framework of the European TURNkey project that I briefly illustrate at the beginning of this presentation. Such support is greatly acknowledged by me and also by my co-authors. I would like to thank you for your kind attention. Thank you very much.